Question 10 on page 346, carrying on with the assess. A lovely question. There's a bit of a twist to it. You have to watch very carefully what it says and just do it. There's a few tricky parts to it. Now, it says an oil storage tank consists of a cylinder, so that's the cylindrical part, with a hemisphere at each end. Hemisphere there and hemisphere there equals a whole sphere, mathematically speaking. Now the cylinder is 1 meter long, there it is from there to there, and it has a diameter of 75 centimeters from there right the way to the bottom there. Trouble is, the metal used to make this cylinder is 1 centimeter thick. If it's 1 centimeter thick and the external diameter is 75, the internal diameter is not going to be as big as 75. If you think about it carefully, if it's a centimeter thick all the way around this metal, then I have to pinch in a centimeter from there and pinch in a centimeter from the bottom there as well, so the internal diameter is actually only 73 centimeters. Alright, you've got to get that into your head before we go any further. So let me just draw what we've got. I like to draw it, this way around if I may. So I've got cylinder, straight bit, and here's the rest like that. Well, it's I'm calling the whole thing a cylinder anyway. So I've got, if you like, a hemisphere there and a hemisphere at the bottom there. Alright, doesn't very hemispherical, but anyway, I have to go with that. Yeah, that'll do. So what have I got then? I have internal dimensions of radius is going to be 73 divided by 2, and that's going to be, I've worked it out here, haven't I? 36.5 centimeters, otherwise known as 0.365 meters. So that's my radius. I also have exactly the same radius at the bottom there. Sorry, it doesn't look quite much like a, what do you call it, does it? Like a hemisphere, but it's supposed to be anyway. And also the radius here equals 0.365 meters, and the height is easy. That's called 1 whole meter. Alright, that's easy. Right, so essentially I've got to work out the volume of the inside of this thing and then worry about converting it into litres. Alright, okay, so here we go. Volume of a sphere is easy. You know the volume of a sphere is 4/3 pi r cubed, which is 4 divided by 3 times, and I always take pi to be 3.14 myself, times the radius cubed, 0.365 cubed. Remember, we've gone from 75 down to 73 because this is 1 centimeter thick. Now it's not 75 take away 1 to give me 74. If I had internal diameter of 74, that will make the walls of the cylinder only 1/2 centimeter thick each side. It's not what it says. Okay, so if you imagine, if you like, there's a smaller, let me just try and give you an idea. Imagine inside here there's a smaller space for the real volume. So I'm looking at something like that. What I've done is saying that is a centimeter thick, that is a centimeter thick. So take away a centimeter from the 75, and that will leave you, of course, with 73 centimeter diameter. I feel I have to label the points because some of you are thinking, why isn't it 74? But if I draw it like that, and what I've drawn, of course, is the yellow internal dimensions. So these are the yellow internal dimensions here, and of course on the outside it's going to be 1 meter thick anyway, 1 meter long anyway, and it doesn't matter about the thickness there in terms of volume, because when I've pinched in the radius down to 0.365, made it smaller, then the 1 meter sort of caves in with it and just falls in line. I can't use better language than that, but I'm hoping you're understanding it by drawing these pictures. Anyway, you don't have to explain all this to an examiner, just get the right stupid number, then that shows you've understood it. And please note we're converting the diameter into a radius. Without that, the whole thing's way wrong. So anyway, volume equals 4/3 pi r cubed, and that gave me an answer of 0.203. I know it's a bit crazy, this 5855 meters cubed. I've learnt not to oversimplify until I get to the end. Now that's the volume of these two halves, here and here, hence the entire sphere. And now we have to do the volume of the cylinder itself, which is the this part here. Very easy. So volume equals pi r squared h, 3.14, same radius, 0.365 squared times the height of 1 whole meter. That's the cylindrical part sorted. That comes to 0.4183265 meters cubed worth of volume. So total volume, let's just work here. I want to get it on one page. Equals the cylinder, or rather the two hemispheres to make one sphere, 0.2035855 plus the volume of the cylindrical part, 0.4183265. That comes to 0.621912 meters cubed worth of volume. Great, it wants it in litres. Okay then. Okay, now a litre equals 1,000 centimeters cubed. Alright, so let's just convert this into centimeters cubed first. Can you accept that if I multiply this by 1, 2, 3, 4, 5, 6, if I multiply by 1,000,000, I get the answer in centimeters cubed. So 621912 centimeters cubed. Now how do you convert that into litres? Simple. Now divide by 1,000 to get it into litres, and that becomes therefore 621912. Of course the decimal point is just there. That's in litres. Let's just finally go yellow. It's probably getting rather invisible down there. So we're looking at approximately 622 litres of oil. So that's 621912. Of course the point is there, 621.912, because I'm now in litres. Roughly 622 litres. That is the answer. Now let me explain why that's the case. Imagine I've got a little cube like this. Again, I better just teach you. This is an aside. The question's done. The answer is 622 litres. Finished. That's correct. We have a meter cube. All right. We've got answers in meter cubes here. 0.62, etc. meter cubes. How's that related to centimeters cubes? Well, simple. If this is an entire meter cube of something, then it's essentially 100 centimeters by 100 centimeters by 100 centimeters. Of course, if these are all in centimeters and I multiply them, I've got 100 by 100 by 100. What have I got there? 1,000,000. I've got 1,000,000 centimeters cubed, and of course that equals the original 1 meter cube itself. Remember, 1 by 1 by 1, 1 meter cubed. 100 by 100 by 100, which is, of course, as you know, 100 centimeters is a meter. So 100 by 100 by 100 is 1,000,000 centimeters cubed. So 1,000,000 centimeters cubed therefore must equal to 1 meter. And you simply have to know that there's 1,000 centimeter cubes in a litre, because a centimeter cubed is 1 milliliter, and there's 1,000 millilitres in a litre. So I simply divided the number here, 261912, by 1,000, and got approximately 622 litres. And that's it. That's what that container can hold. And now I'm going to do the AQA question for the final video. It's short and sweet and really, really easy in my mind, and that's great. So see you quite soon. We are done.